Hello everyone, welcome to this lecture on how to convert decimal number to binary number and binary number to decimal number. First question is, why do we need number conversions? The answer is because humans and computers use different number languages. Humans use decimal number system which has digits 0 to 9. For example, we easily understand the number 13 with digits 1 and 3 in decimal number system. But computers don't work in decimal internally. Computers use binary number system which has digits 0 and 1. So decimal number 13 becomes 1101 in binary. So we need conversions to communicate between humans and computers. Also, to understand computer calculations and learn programming. You will see binary numbers in computer calculations and programming. So, conversions help you to understand what is happening inside the computer. In some cases, binary number becomes very long. You can see here. So to simplify the long binary numbers, humans use decimal form, which is short, easier to read and write. So we can write a number in different ways. Same number, but different ways of writing. Remember that conversions don't change the value, they only change the representation of the number. Now, let us understand what is a number system. A number system tells how numbers are written and interpreted using digits and a base. So every number system has two main things. One is digit and second is base. In decimal number system, digits 0 to 9 are used. Base for this number system is 10 and each digit position has a weight equal to the power of 10. For example, the decimal number 345 decimal point 6710. So this is the decimal number system and this 10 represents the base. Here you can see digit 3. Digit 3 is at hundreds place. So weight for digit 3 is 10 raised to the power 2 means 100 and digit 4 is at tens place. So weight for digit 4 is 10 raised to the power 1 means 10 and digit 5 is at ones place. So weight for 5 is 10 raised to the power 0 which is 10. After decimal, you can see digit 6 we have. This digit 6 is at tenth place. So weight for 6 is 10 raised to the power minus 1, which is 1 by 10. And weight for 7 is 10 raised to the power minus 2, which is 1 by 10 square means 1 by 100. So it is at hundreds place. In binary number system, only two digits 0 and 1 are used. Base for binary number system is 2 and each binary digit that is called bit also. So each bit position has a weight equal to power of 2. So in decimal number system we use power of 10. In binary number system we use power of 2. For example, so this number is written in terms of two digits only. So 10110, and this 2 represents the base of this number system. So this is a binary number. So you can see here this digit 0 is at ones place. So wait for this digit is 2 raised to the power 0. Okay, and this digit is at 2's place. Okay, 2's place, why we say? Because wait for this digit is 2 raised to the power 1 equal to 2. So it is called 2's place. Okay, now after decimal point, if we talk about this digit 1, so wait for 1 is 2 raised to the power minus 1, which is 1 by 2. So we can say half. And for this digit, weight is 2 raised to the power minus 2. So it is 1 by 2 square. So we can say it is 1 by 4. And for this digit 0, weight is 2 raised to the power minus 3. So we can write 1 by 2 raised to the power 3 means 1 by 8. Okay. So in decimal number system, we use powers of 10 for weights of digits, but in binary number system, we use powers of 2 for weight of all bits, means for all binary digits. So weight concept is the foundation of all conversions for any number system. Now we will learn how to convert a decimal number into binary number. So example is, convert the decimal number 10.625 with base 10 to a binary number with digits 0 and 1 only with base 2. So this decimal number has two parts. One is integer part, which is 10, and fractional part, which is 0.625. So we convert these two parts separately. So for integer part conversion, we use the method that is repeated division by 2. So here we divide the integer part 10 by 2 and record remainders. So we divide 2 5 ja 10. So remainder will be 0. Now again we divide 2 2 ja 4. Then remainder will be 1 now. Now we divide again by 2. So 2 1 ja 2. So remainder will be 0. Now we divide again by 2. So 2 2 0 0. So 1 minus 0, remainder will be 1. Now we write remainders from bottom to top, means we record number as 1 0 1 0. So we get binary number 1010, which is a binary number with base 2. So integer part 10 in decimal system is same as integer part 1010 in binary system. So in this conversion, important rule is stop division when quotient becomes 0. So you can see here. Now, how to convert fractional part of decimal number to binary number. So here fractional part is 0.625. So for fractional part conversion, we use the method repeated multiplication by 2. Okay, in integer part conversion, rule was repeated division by 2. Here for fractional part, we use the method repeated multiplication by 2. So multiply this fraction with 2, we are getting 1.25. So in this number, the integer part is 1 and fractional part is 0.25. So here we record the integer part of this output, which is 1. Now we take fractional part of this number, which is 0.25. We again multiply this fractional part by 2 and we are getting 0.5, and in 0.5 integer part is 0, so we record this integer part here, it is 0. Now in 0.5 fractional part is 0.5. Okay, so we take this fractional part from here. Okay, we take fractional part from here and we multiply by 2, we are getting 1.0. So in 1.0 integer part is 1, and now fractional part becomes 0. So now in fractional part conversion, we write integer part from top to bottom. So number will be 1, 0, 1. So we get the fractional binary number as 0.101 in binary form. So for fractional part conversion, important rule is stop stop multiplying by 2 when fractional part becomes 0. Okay, so this is very important to know when we need to stop dividing by 2 in integer part and when we need to stop multiplying by 2 to a fractional part. Okay, so now we combine integer binary form, that is 1010, and fractional binary form, which is 0.101, and the corresponding binary number will be 1010.101 with base 2. Now let us convert a binary number into decimal number. Here given binary number is 101.11 with base 2. So again we split the binary number in two parts, in integer part which is 101 and fractional part which is 0.11. So for binary to decimal conversion, we use the place weights of bits, which are powers of 2. Okay, so for integer part we write 101, which will be equal to weight for this digit, it is 2 raised to the power 0 for this one, and for this 0 weight will be 2 raised to the power 1, and for this bit it will be 2 raised to the power 2. Okay, so now we are getting 2 raised to the power 2, it is 4, 4 multiplied with 1 it is 4, then 0 multiplied with 2 it is 0, plus 1 multiplied with 1, 2 raised to the power 0 is 1, so we are getting 1. So finally we are getting decimal number 5 here. So now we convert fractional part, which is 0.11, to uh, decimal number, decimal fraction part. So in binary, fractional places use negative powers of 2. Okay, so here the fractional part, that is 0.11, it will be equal to 1 multiplied with 2 raised to the power minus 1. So for this one, the weight will be 1 by 2, means 2 raised to the power minus 1, and for this one, it will be 2 raised to the power minus 2. So we can write it is 1 multiplied with 1 by 2 means 0.5 we are getting, and from here we are getting 0.25. So finally we are getting fractional part of binary number in decimal form, which is 0.75. Okay, now we add integer part and fractional part both. So for integer part we are getting decimal number which is 5, and for fractional part 0.11 it is converted to 0.75 in decimal form. So after adding both parts we are getting 5 integer part 0.75. So binary to decimal conversion is very simple. Simply what we do, we multiply each bit with its weight and then add. Okay, so for integer part we use positive powers of 2, means starting with 0, 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, and for fractional part we use negative powers of 2 for weights of bit. Now let us see some interesting and important cases. Sometimes when we convert a decimal number into binary, the binary form becomes non-terminating. That means it does not end. For example, root 2 with base 10 means this is in decimal form. So root 2 is approximately equal to 1.4142. Okay, but its binary representation is approximately, you can convert this root 2 to binary number which will be 1.0110 and so on. So this binary expansion does not terminate. Okay, here digits goes to infinity. Okay, second example is pi. Pi is approximately equal to 3.1415. Okay, in decimal form we are writing here with base 10. In binary it becomes approximately 11.001001 and so on. Okay, so again it is an infinite repeating pattern. You can see here 0.001 001 001 001. Okay, so this is infinite repeating pattern. Third example is 1 by 3 in decimal form with base 10. We can write it is 0.3333 and so on. So in binary it equals to 0.010101, okay, with base 2. So it also becomes repeating in binary. Fourth example is 0.1, which is a decimal number. So when we convert this decimal number to binary number, we get 0.0001100011000011 and so on. Okay, in binary form. So it also has the infinite repeating pattern. Okay, so important conclusion is some decimal fractions cannot be represented exactly in binary, and that's why computers sometimes shows small rounding errors, because computers can store only numbers with finite digits. Okay, so for to store those numbers with infinite number of digits, they use the rounding or chopping off those numbers. So friends, today we have learned why number conversions are needed, what is number system, and how to convert decimal to binary and binary to decimal number. If you found this lecture helpful, please like the video, subscribe to the channel, and share with your friends. And if you have any doubt or questions, write them in the comments. Thank you very much.